How about last time class? How was that? Did you understand?
Fine, sir. Yes, sir.
Okay. Yeah, let me share the slide.
Yes, sir.
Yeah. As we discussed last time, the relation between the like velocity, acceleration, displacement. Let me. I think you guys know that. Can you define the velocity? What is the velocity? What is the velocity?
Velocity.
Yes.
Rate of change of displacement.
Velocity is equal to,
Rate of change of displacement. Yes, sir.
yeah, ds by dt, right? Which
Yes,
means
sir.
delta s by delta t. So change in displacement with respect to time, right? As you increase the time, if you can observe that there is a change in displacement, in that case, we can say that there is a velocity. So from the first graph, here you can see that along the y-axis we have the velocity, along x-axis we have the time. As I can see from this graph, right, along as you increase the time, let us say 5, 10, 20, let us say, or 15, it doesn't matter. So the velocity, you can say this is the 10, okay? So velocity is not
Yes,
changing
sir.
with respect to time, right? Is it?
Yes, sir.
It's a constant, right?
Yes, sir.
So from the first graph, we can say that velocity is constant, but what physical quantity is zero from this graph? What physical quantity is zero, Pranav?
Acceleration.
Sir, physical acceleration.
Yeah, because there is no velocity change, right?
Yes, sir.
So according to the acceleration definition is rate of change of velocity, right?
Yes, sir.
V by dt, delta V by delta t. If there is no change in delta V, you can simply say it is equal to 0. From the first graph, we learned that velocity is constant over the time. If the velocity is constant, we can conclude that acceleration equal to 0. Is it clear?
Yes, sir.
Right, this is clear. So coming to the second graph, okay. So
Sir,
this graph also along x-axis time, along y-axis velocity. Now tell me what is going on here. Can you describe about this graph, Pranav?
sir. Yes, sir. Means velocity is increasing, sir.
Yeah, velocity changing with respect to time. But how is it changing? Do you think it's uniformly changing, or does it changing some changing like, does it changing without uniformation? Like, is there can we say here acceleration? Do you think there is acceleration here?
Yes, sir.
Is it uniform acceleration, non-uniform acceleration?
Non-uniform.
No, no. What is the meaning of non-uniform and uniform? Uniform means,
Uniform means with same interval of time.
no, if uniform means the acceleration should be constant, right?
Yes, sir. Yes, sir.
So here, if I say if I find the slope here or
Yes,
here
sir.
or here, if I can get a acceleration is same, a1 is equal to a2 is equal to a3, then you can conclude that acceleration is constant, right? So if
Yes,
I
sir.
plot that graph, so this should come like this. If there is no change in if the acceleration is same, if I plot the
Sir.
graph between the acceleration versus time, so the graph should be like this. Can we get like graph like this from the above graph? Because
Yes, sir.
here the velocity is increasing, right? With respect to time.
Yes, sir.
Can we say that velocity, the change in velocity is uniform or not?
Yes, sir. We can say so.
It seems like a uniform. I mean, if I give the numbers, you can easily conclude it, but I did not mention here the numbers. Without, the numbers of velocity and time, we cannot say whether it's a uniform or not, but it seems like a change seems like a uniform. If the change is uniform, acceleration is also constant. Acceleration is constant. Okay.
Yes, sir.
Every point you should get actually same acceleration. So coming to the last C graph. So coming to C graph, what is the difference between the B and C?
Not understand.
No, A is increasing, right? What about B? Sorry, what about C graph? B graph, I can say that velocity gradually increasing with respect to time, right?
Yes, sir.
So you can think about it here. What is the velocity here? 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 As you increase the
Yes.
time, what happened? Velocity.
Sir, no, not
No,
understand.
no. Think about you understand. You can just think it. So how velocity changing with respect to time? Does it increasing?
Yes, sir.
Really? Can you see that?
It's increasing now, sir.
How? Tell me. So this is,
One it's decreasing, sir.
no, no, tell me. You just think about it. Don't confuse it. So my, let us say I'll give the numbers. 30 meter per second. Here 25, maybe here 20. So meter per second. So as suppose here 5, 10, 15, 20 seconds. So at 5
Yes, sir.
seconds, what is my velocity? 30. At 10
Yes, sir.
seconds, 25 meter per second. At 15 seconds, 20 meter per second. At 20 seconds, 0. So does it increasing or decreasing? Pranav.
Decreasing, sir.
So velocity is decreasing, right?
Yes, sir.
If velocity decreasing, what you can conclude that? Acceleration is it retardation or acceleration? Acceleration means positive. If it is negative
Yes, sir.
acceleration, we can call that as a retardation, deacceleration or retardation. Like stopping bike. Like when you see the speed breakers, what you do? You just stop it, right? Like you just control your brakes and decrease the speed of the vehicle, right?
Yes, sir.
So that is called deacceleration, means you are stopping, you are applying the force with the help of brakes to stop the
Yes, sir.
car, bike, etc. Okay. In case
Yes, sir.
of B case, in case of diagram, here you are
Sir.
increasing, you are placing your leg on the, what do you call, we increase the speed, right? Accelerating. We are
Yes,
accelerating
sir.
the car by placing your leg on the accelerator. You are going faster and faster like that. Here you are going slower and slower and going to be stop, 0. So this we call retardation and this is called acceleration. Okay.
Yes, sir.
How about this graph, D graph? What you can tell that about it? From that diagram, what you can conclude? What it seems like that? At 0?
I don't understand, sir.
No, no, no. First you think about it, Pranav. I mean, from that diagram, what you can like what you can getting actually, what information you are trying to get it, because it seems like at zero there is a something is here, right? The velocity is let's say
Yes, sir. Velocity.
even at zero, even you are at zero, the body has some velocity, right?
Yes, sir.
Let us say 5 seconds later also it's velocity increasing. Let us 10 seconds later the velocity slightly increasing. 15 increasing. So it has initial velocity, right?
Yes, sir.
So it's not rest. It is not at rest. Okay. It
Yes,
is
sir.
not at rest. The body, if someone asks you from that diagram, is the body at rest initially? No, because I can clearly see that it has some velocity even at zero time. Okay. So as you increase the
Yes, sir.
time, the velocity gradually changing, but it's not like a uniformly. I would simply
Yes, sir.
say it is not a uniform. So if there is no uniform change in velocity, you can also have the acceleration, which is not equal to zero or it is not even constant. Okay?
Yes, sir.
I mean, you can simply say calculate it. You calculate
Sir.
the, I mean, if you know the numbers, okay, you can able to calculate it easily. So
Yes,
you
sir.
you calculate the like slope here. Slope you can clearly see how it is increasing. Can you see here? The
Yes.
slope is here is small. If I can say here increasing slope, right?
Yes, sir.
So the triangle size also you can see simply. So slope is increasing. Okay.
Yes, sir.
So acceleration also changing. Coming to the E. So what is the
Yes,
E
sir.
actually? What you observe? Can you explain about this graph? What is going on? You just think, Pranav. Don't say no. Okay, you try. So here also along y-axis, well, velocity along x-axis.
Sir, non-uniform motion, but velocity is increasing, no, sir?
Yeah, non-uniform. Definitely, it's non-uniform motion. Velocity initially you can see it's changing different. Then when you go higher, velocity is increasing. I mean, the slope is much higher here. If I calculate here, if I calculate here, if I calculate here, definitely here almost like a zero velocity. So the change in velocity is much smaller here. Suppose if I give the names A, B, C, I can say the velocity big change should be at C point, C region compared to B and A. So when the velocity changing larger, you could expect the acceleration also larger in C region, right? So more velocity
Yes, sir.
change, more acceleration. Less velocity change, less acceleration. If zero change in velocity, zero acceleration. I mean, acceleration is zero. If there is no change, completely constant, if constant velocity means what? There is no dv is equal to zero, right? If dv is zero, a is equal to zero. If there is
Yes,
no
sir.
change in velocity, whenever you see this kind of situation, when there is no change in velocity, simply can say acceleration equal to, right? Zero,
Yes, sir.
right? Pranav?
Yes, sir.
Whenever there is no change in velocity, like delta v equal to zero, which means what? Final velocity minus initial velocity equal to
Initial velocity.
zero, or v1 is equal to v2. Like always it's a v1, v2, always same. Whenever you
Yes,
see
sir.
the velocity is constant, which means acceleration equal to zero, right? What is the acceleration?
Yes, sir.
There should be a change in velocity, right?
Yes, sir.
If there is no change in velocity, there is no acceleration. So last graph. Tell me now. This is your job to explain. First A to B. You have to describe what is going on A to B. So here velocity
A to B.
versus time graph.
Yes,
So
sir.
at A point, what is the velocity of object? 0, right?
0, sir.
At B point, let us say I can give the numbers also here. Maybe I can give 10 here. 10 meter per
Yes, sir.
second. Okay.
Yes, sir. Okay.
Uh, so let us say 5, 10, 20, 30. So tell me now,
Yes, sir.
A to B, does velocity, how velocity changing? How velocity changing from A to B? It is
A
increasing,
to
right?
B. Yes, sir. Increasing, sir.
It is increasing with respect to time. What is the slope of this? If I ask you, what is the slope of AB? How do you calculate slope? Y2 minus y1 by x2 minus x1.
Yes, sir.
So what is the component here? Like if I want to calculate this slope, I should need to know the coordinates at A and B. B, what are the coordinates of B? Here 10, right? 10 comma
Yes, sir.
10. The coordinate at B is 10 comma 10, right? X component 10, Y component also 10. Is it?
Yes, sir.
So how about A point? A is again from here to here is 5, right?
Yes, sir.
So here Y component is 0, right? So
Yes, sir.
so I can say 5 comma 0, right? So
Yes, sir.
did you understand? Along on the x-axis, Y component is 0, right?
Yes, sir.
So x component 5, y component 0. So slope, if you want to
Yes, sir.
calculate the slope equation, m is equal to y2 minus y1 by x2 minus x1. So here you can give like, this is x1, y1, and here x2, y2. So y2 minus y1, difference in y coordinates. So 10 minus 0, 10 by x2 minus x1, 10 minus 5. So 10 by 5. So 2. Slope is 2. Is it clear, Pranav?
Clear, sir.
How about BC? So BC, what is the property of this BC motion? Suppose if I ask you, can you explain the BC, the motion of object? What is going on here?
Yes.
Tell me, Nano.
Yes, sir.
So BC, how the object changing from
BC is being constant, sir. And
okay.
means in rest, sir.
So yes, the body is not
After that,
changing.
After that,
It is at
velocity
let me
decreases.
ask question. Is it at rest or uniform constant motion?
It could be both, no, sir.
No, is it a rest or uniform motion? Tell me. Constant motion. Is it constant or 0?
Constant, sir.
Yeah, because it's already 10, right? So 10 meter per second. It
Yes,
is
sir.
not changing. So it is not changing, just constant. Okay. So slope also 0, right? If I ask you to
Yes, sir.
calculate slope, what is the acceleration of this graph? 0, right?
Yes, sir.
There is no change in velocity, right? So A
Yes,
is
sir.
equal to 0. So coming to CD, what about CD? Velocity is
Uh,
decreasing with respect to time, right?
yes, sir.
So velocity is decreasing with respect to time. So retardation, it has object as a retardation here. You are stopping the vehicle. Simple, Pranav. A
Yes,
to
sir.
B is you are raising the bike, like increasing the velocity. B to
Sir.
C is you are going uniformly without speed breakers. You are going like a very constant motion. C to D, you are some like you saw the speed breakers. You want to go the slow, and you are stopping it. Okay, very
Yes,
simple
sir.
example. Okay,
Yes, sir.
so is it clear now from the graph? I think you understand, right?
Yes, sir.
Can I clear it,
Yes, sir.
or did you copy everything? Screenshot or whatever, I don't know.
Yes, sir.
Okay, I'm clearing.
Yes, sir.
Okay, okay. So tell me now, here there is one more graph. Here there are three graphs there. Displacement, velocity, and acceleration. Okay. So did you observe the graph here? This is
Yes,
the
sir.
displacement versus time. Here velocity versus time. Here acceleration versus time. Pranav,
Yes, sir. Yes, sir. Yes, sir.
this is a very important graph. You should understand what is going on. Here, from this graph, actually, you can, correlate you can relate actually how velocity is related to the displacement, how acceleration is related to the velocity, how these three parameters are related.
Yes, sir.
So simply parallelly, you can able to see. So suppose if I observe the displacement versus time graph, so you are at year 0 first. I want to check from year to year, all parameter, like within 5 seconds, I would say. So 5
Yes, sir.
seconds, you can see all three graphs. So displacement is changing with respect to time, right?
Yes, sir.
How does it change? How is it changing? Is it uniformly changing?
Yes, sir. No, sir. No, sir.
There is no uniform way, right? Here slope is less, here the slope is increasing, right?
Yes, sir.
Pranav, easily you can catch it. This is very simple. If I have here, there is no slope, completely at zero. As you go up from here to here, slope is increasing, right?
Yes, sir.
Slope increase. So you can also see velocity. As you as you can see here, displacement changing with respect to time, and you can see clearly velocity constant, velocity changing uniformly increasing. Okay,
Yes, sir.
when the velocity is uniform with respect to time, acceleration is constant, right?
Yes, sir.
If velocity is constant, if velocity is changing constant, not constant, velocity constant, acceleration equal 0, but velocity changing with respect to time uniformly. Did you get my point?
Yes, sir.
I'm not saying, suppose if it is like this, acceleration 0, right?
Yes, sir.
Can you see here my line when I draw like here? If if I want to calculate this, acceleration 0, but here my velocity changing uniformly increasing, so acceleration is constant. Did you understand?
Yes, sir.
Please let me know if you don't understand. So coming to the next
Understand,
point.
sir.
Coming to the next point. So 5 to the, like, maybe I think, I don't know how much it is, but let us observe these points. Whatever points here I am note down with green. So tell me now, when I move from year to year, okay, it seems like a increasing, but uniformly increasing, right?
Yes, sir.
Displacement is increasing, but almost like uniformly. Increase should be uniform. From the initial point 0 to from this point is not uniform, like curvy motion. Like there is a curve, right? Here you can
Yes,
observe
sir.
that it's like a straight line. Approximately, approximation actually. It is a straight line, increasing linearly. Increasing linearly.
Linear.
Whenever the displacement increasing linearly or uniformly, velocity is constant, right?
Yes, sir.
The slope is changing constantly, uniformly. If it is constant, if it is displacement is constant, velocity zero. But here displacement is not constant, increasing but uniformly. Displacement is increasing with respect to time, which is uniformly. So that velocity is constant. When the velocity is constant, acceleration what happen? Zero, right?
Zero.
Yeah,
Yes, sir. Yes, sir.
there is no change in velocity. Suppose here 10, here 10, everywhere is 10 from year to year. So acceleration is change in velocity. So 10 minus 10, 0. So
Yes, sir.
acceleration is equal to 0. So when displacement increasing linearly, uniformly, and velocity is constant, acceleration becomes 0. See how they are related? One is increasing linearly, the other one is constant, the other one equal to 0. Right? So now, from this to this point, completely curvy motion, curvy linear motion, right? Curvy motion, completely curved. So let
Yes,
me
sir.
change the color now. From here to here, so you can think about this. So completely the displacement changing differently, right? It's not like, so from year to year, the way of changing is different. From year to year, changing is different, right? Did you catch my point here?
Yes, sir.
Pranav,
Yes, sir.
from
Yes, sir.
year to, suppose if I say A to B and C, A to B, it is changing, should be increasing, right? Right?
Yes, sir.
So velocity, like increasing, then finally decreasing actually. Up to here, slowly, the slope you can check it. What is the slope here? What is the slope here? What is the slope here? It is zero slope, right? So here
Yes, sir.
1, 2, 3, almost like a zero here. Did you observe it? The slope actually initially is high. Finally, it becomes zero, right? Pranav.
Yes, sir.
The slope at A is much higher than the at B. So B almost like a parallel, constant, right?
Yes, sir.
When there is no change in displacement, you can say velocity is zero,
Yes, sir.
right? So at this
Yes,
point,
sir.
if you observe at this point, velocity is zero. Okay. So that is the velocity is decreasing. You can clearly see that. Velocity is decreasing. Okay. From B to C, what happened? Displacement is also decreasing, right?
Yes, sir. Yes, sir.
But negative way, decreasing completely. Maximum to the minimum. Maximum to the minimum. You can, here slope is zero, right? The slope is changing. You can draw like this to
Yes,
understand
sir.
clearly. The slope is almost like a zero from this zero. So as you go up, the slope is zero. So here zero, slowly increasing slope, right? Slowly increasing slope at this point. At C, Again, what happened? Tell me. Let's see the points. You can see the changing is the slope changing is much higher, right? But it is decreasing here almost like a parallel. So when there is a when there is no changing, velocity is zero, right?
Yes, sir.
You can see clearly there is a curve here. So, but the curve is decreasing. So the velocity decreasing. When the velocity decreasing, so here is more slope. So the change should be uniform decrease. The acceleration is constant. From here to here is acceleration constant. So I did not explain this part now. So what happened here? From here to here completely constant velocity decreasing, right? Constant. So that is the reason completely constant acceleration. Velocity changing uniformly from A to C. So A to C, the velocity changing is the uniformly changing. So when the velocity changing uniformly, you can think about acceleration is constant. It's not changing completely. Okay. So,
Yes, sir.
I mean, when the velocity zero, acceleration also zero. Is it, did you understand?
Yes, sir.
So this is like a comparison of displacement, velocity, acceleration. Satvik? Satvik, are you there? Okay. So now, can I clear it, Pranav?
Yes, sir.
Okay, I'm going to clear it now. Did you take
Yes, sir.
a screenshot?
Hello,
Yes.
sir.
Did you copy
Sir,
it?
my voice. Sir, my
Did you?
voice break. I
No,
think,
no.
sir.
Did you take a screenshot?
Hello, sir. Your voice is breaking, sir.
Did you take screenshot?
Now voice is clear, sir. My internet was lagging, sir.
Okay. Did you take screenshot of this?
Yes, sir.
So coming to the equations of motion. So what are the equations of motion? What do we do with them? So equations of motions are the motions, right? So these are the equation we use to describe the motion of object. Okay. These are the equations. We have 4 equations of motion here, which could be used to describe the motion of objects. Okay. But what is the condition, Pranav here? What is the main condition here? Satvik, what is the condition? The condition is uniform acceleration. A is constant. We take here A is constant. Someone asks you, what is the assumption they made while they are writing these equations? The assumption is acceleration. They assume that the object is in constant acceleration. Okay, Pranav.
Yes, sir.
So remember this. A is constant. So these are the 4 equations you have to remember. V is equal
Yes,
to
sir.
U plus AT. Suppose if they give the initial velocity of the object, final velocity of the object, A is the acceleration, T is the time. Then you have to use this equation. This is the first equation. Then if they give the displacement or distance, you have to use this acceleration, initial velocity, time, distance. So you have to use S equal ut plus half at square. And the
Yes, sir.
also related to the, but if they don't give the time, Initial, they give you the initial and final velocities, acceleration, distance. You have to use these equations. The last equation is also important. Suppose when you throw a ball, and if I ask you what is the distance, what is the velocity at nth second, what is the distance traveled by the object at nth second, like first second, second second, third second, like that. If I ask you like that, you have to use this fourth equation. Nth time. So what is the distance traveled by object? 10th second, like that, with respect to the first second, like 0. So then you have to use this fourth one. Okay. So these are the four equations are very, very useful to understand mechanics. And these are the
Yes, sir.
fundamental basic equations. So if you don't know, if you don't understand these equations, you can't deal with the mechanics. Okay.
Yes,
So
sir.
I think next class I'll try to explain briefly about these derivations, and then we'll do some problems, and we'll do some applications where we can use this equation, how to use this equation to handle the problem, various problems. Okay.
Yes, sir.
But whatever we complete, you have to expert, like don't you just practice and come up with some doubts every class. And here I mentioned some of them, like this is a special case. Suppose in case of freely falling bodies,
Sir.
so object, you just release the object towards the ground. So free, we call it freely falling bodies. Freely falling bodies means you just throw the ball from certain height. You just initial velocity is 0. In that case, initial velocity equal to 0. You just need to substitute u is equal to 0. And a is equal to g. G is the acceleration due to gravity, right? You always take the a is equal to g is positive towards the ground. A is equal to plus g. So g is always positive towards the ground. A is equal to minus g when you are throwing object vertically upward. Okay. So now we are not doing a vertical motion. So we are doing the here freely falling bodies motion. Simply I am substituting u is equal to 0, a is equal to g. So the first equation is what? V is equal to u plus at, right? So here a is equal to g. Okay, u is equal to 0. So when I substitute u is equal to 0, I can get v is equal to gt. V is equal to, so this is actually I this is a vertical case I wrote here, but freely falling bodies I did not. I think that I missed the slide. I missed the slide. I think I missed the slide. Yeah, here you can see here. I think time is off. Maybe we'll discuss next class. Okay, Pranav?
Yes, sir.
Yeah, we'll discuss next class all the freely falling applications, derivations. Okay? Okay, see you then. Good night.
Yes, sir.
So all the best. Just go through all the concepts that we completed today. Okay?
Yes, sir.
Right. Thank you. Yeah, I think so.